Okay, we're going to go ahead and get started. Again, thank you all for attending. I'm excited today to work with my very trusted partner, House of Brick Technologies. We have the privilege of having Dave Welch with us. Dave is going to be leading the majority of our discussion today. Dave, if you could advance to the first slide for me, please. So guys, I want to start off with a real brief introduction of Sayers and kind of get some things teed up on that side. First of all, I know there's going to be questions that are going to pop up throughout this webinar. If I could ask you to do me a favor and submit all questions via chat, that way we can not only have them and have them recorded along the way and do our best to answer them as we can. We're going to basically try and summarize all of the questions and answers at the very end of the webinar. We're planning on leaving about 10 minutes at the end for time to go through and do that. So thank you for that. So real quick, Sayers, who we are. Sayers has been around for a good period of time, a little over 30 years at this point, and we really specialize in areas of expertise around infrastructure. Our goal for all of our customers is first and foremost to seek and understand who you are and what you need from us as an organization. From an area of focus perspective, my areas, I own the data center side, so I've got storage and virtualization, networking, infrastructure as a service at this point also. And so when we began to look at virtualization many moons ago, it went from a real cool technology into where it is today, business critical. We have been for the last several years, last 3 to be honest, working with House of Brick in regards to helping our customers virtualize their core virtual database workloads. It's been an exciting process for us along the way, and it's been wildly successful. There are many benefits to this process, not only from a licensing perspective, but an operations perspective. And so we're really proud today to go through and put this webinar on with our partner, House of Brick. Dave, why don't you go ahead and take over? I'm going to have you introduce yourself, and then we'll go ahead and get started on the actual meat of the webinar.
Certainly, Bill, thank you very much. We very much appreciate the opportunity to team with Sayers in general at the very scaled strategic customers that we've helped with Tier 1 database virtualization. And we're thrilled to talk about some of that today. House of Brick is a team, performance, hardware sizing, business continuity team, has been around since 1994. We've been commercially available entity since 1998, Omaha-based. We happen to lead the world in time and in count in Tier 1 Oracle and VMware production workloads. Been doing that in scaled environments since 2006. We also, for well over a decade, have had a very significant percentage of our business based on SQL Server. We specialize in business critical application performance and the transparency of that compared to native hardware. Key services, obviously, cloud architectures. We're very good at risk replatforming to Linux on vSphere. Oracle and SQL Server specialties. We have a substantial Oracle license internal audit and audit defense business practice. And we also do managed consulting services. There are, I'll highlight 6 of those that I could. Any one of these reasons is justification alone to virtualize mission critical workloads, even dedicated mission critical workloads. My favorite happens to be approaching 100% reliable DR, something that is manifestly impossible in a native hardware environment. We'll talk more about that later. Product lifecycle optimization. More features in a release with fewer people involved, with a better QA and less calendar time. What's not to like about that? Cost reduction will focus both on license reduction, optimization, as well as hardware consolidation. High availability for workloads that otherwise may need literacy and custom coding, and yet VMware brings high availability for the workload masses. Security. A lot of people don't know and haven't considered that a properly configured virtual machine, even without any of the add-in VMware security products, is inherently more secure than its native hardware counterparts. That, for me alone, if I were C-level in industry, would be justification to have serious plans to get moving as quickly as possible to throw the virtual shroud even around my dedicated workloads. An extreme HA, meaning HA that as of January 2015 needs to have absolutely no downtime, not even a client disconnect if I lose the entire physical hardware underneath a workload. That's made available now with VMware's SMP fault tolerance, groundbreaking product that we'll talk about more later. So, just a few case studies. One that we love to talk about because of the scale, Indiana University. I've got 6 different IT divisions. They're so large. 5 years ago, we helped them, and they encouraged us to talk about it very openly. 2 fairly public failures with virtualization happened to be Oracle. One was a technical failure. The other one was more organizational, and they called VMware, who called us, and we went in and helped them resolve both of those, and also provided them transparency, performance transparency with their mission-critical workload. We eliminated their AIX risk Unix expense and enabled them to do something that would have been unheard of previously, live migrations with no downtime to their new data center across the street. State and provincial governments, we have a significant public vertical. We do a lot with these organizations to help them with consolidation as well as business continuity. Another one that I'll mention, a national trade organization that was very dependent on Oracle RAC, and they determined that RAC was no longer strategic for them. I'm not saying that RAC is not appropriate for some workloads. It most absolutely is, but probably 2/3 of the customers that we could not envision any other solution for than cluster, database level clustering, whether it be Oracle, RAC, or SQL Server clustering. 2/3 of those we can no longer justify for those database level clustering. And now they're single instance on VMware HA and very, very happy. They've been that for years now. So, reducing costs. Not all workloads in the US, just most. In North America, native hardware, bare metal, we have to size them for peak processing that takes place on the batch cycle on the swing shift. Daytime, it can be not unusual at all to have average CPU utilization of only 5 to 15%. Well, that's great for the relational database vendor in terms of the size of the deal, but can be suboptimal in other ways. Properly configured vSphere clusters or subclusters, we have customers that approach 50, 60, 70% average CPU utilization with those clusters, with a marvelous noisy neighbor isolation between their workloads from a performance perspective, and an incredible optimization of their license. So Oracle, you're not going to look for the same levels of consolidation. I remember at VMworld 2005, they were talking about nameplate customers that had consolidated anywhere from 13 to 30-fold. You're not going to see that generally with most Oracle production workloads, but consolidation ratios of between 150 to 300% are not unusual at all. So from a license optimization perspective, if you were to compare a IBM AIX Power 7 Plus chip core to an Intel Ivy Bridge core, the one with Oracle is priced at a 1.0 processor to core factor, but yet the x86 core is priced at 0.5. And the fact that that Ivy Bridge core will outchase by about 30%, according to Spec Int publicly available benchmarks, the Power 7 Plus chip. Add those two together and you're looking at in the neighborhood of a 240% license optimization. That's even before any CPU consolidation. So you can get respectable consolidation ratios on your relational database licensing that can be very attractive. So if Oracle were in the parking lot business, we have here a hapless person that assumed to drive into this parking lot and on the way out exclaims, $1 billion to park my car. And the attendant says, well, we had to charge you for every spot since you could have parked anywhere. This may remind you some of you of experiences that you've had where Oracle has represented that you have to, for example, license the entire vSphere cluster for Oracle, not just that subset of physical vSphere nodes where the Oracle-laden virtual machines are constrained and beyond which they do not travel. going to focus on Oracle here for a few minutes for no other reason that, you know, I haven't encountered another software manufacturer, to my knowledge, that where there's any disagreement between what's in the contract, what the sales team represents, and what the end users understand. For example, SQL Server 2012, in some editions, the licensing went to core-based. Nobody liked it, but there was no disagreement at all as to what the policy was, what the contract stated. So here's a list of assertions that we hear by Oracle reps that have no contractual merit. First off, soft partitioning, which Oracle itself defines as limiting the number of cores in a single physical server for licensing purposes, that is disallowed. The second assertion that has no contractual merit is that subcluster licensing, I mentioned that a moment ago in the parking lot scenario, is disallowed. You have to license the entire cluster, so you're told. Third assertion is that soft partitioning may also be a cluster level concept, and no, it's not by Oracle's own definition. Fourth assertion is that the so-called 10-day rule becomes moot when you're running on VMware. Fifth assertion that has no contractual merit is that as of vSphere 5.1, all vSphere nodes that share the same storage must be licensed. And the last assertion is, as of the advent of vSphere 6, that the entire enterprise, all vSphere nodes anywhere in the enterprise, require licensing. So, about to show you that none of these has any contractual merit. Doesn't matter how old or how. Please.
Dave, I take it that you've heard all of these licenses or all of these arguments from Oracle reps along the way when you're working with your customer subset. Is that correct?
Yeah. Both Oracle sales rep, Oracle auditors, also known as license management services. We hear it directly as well as indirectly through our customers that these statements have been made. And a lot of these statements now are out in the public domain. So it doesn't matter how old or how new your contract is, it's got this statement in it that is materially identical. Processors shall be defined as all processors where the Oracle programs are installed and or running. End of quote. Installed is past tense. Running is current tense. There's nothing in there about licensing some other node where you haven't moved to, but that you may have the capability of moving to. Nothing prospective in the contract. So there are a handful of Oracle licensing policy documents. You can Google them right up, public facing. Let's look at which of those are actually contractual. The Oracle Technical Support Policies, I'm quoting out of a publicly visible December 2010 OLSA template. That is indeed integrated into the contract by this contractual language, and it gives a URL where that can be found. Also, the Oracle processor core factor table that any version of the contract, August 2008 template and newer, integrates that document directly into the contract by direct reference. Your contract also has an entire agreement clause that basically states that upon bilateral execution of the contract, any and all verbal or even written representations that are not in line in the contract itself or directly referenced in the contract are hereby null and void. Very important.
So Dave, I think that one becomes very important because of the sales process generally, right? Because a lot of times we're necessarily not told things that are contractually accurate during the sales cycle or the relicensing cycle. And so this really says it doesn't matter what was said. If it's not written, it's not written.
Yeah, and not only, exactly, Bill, and not only if it's not written, it can be written and it can be it can be public facing for years and very unambiguous. But if it's not integrated into the contract, it doesn't matter how pretty, how nice it is, how often it's repeated, and by whom. It's non-contractual. Okay. So let's just run through these. The software investment guide, it's not contractual other than one statement in it that we have found. I really don't care because everything in it aligns with the contract with the exception of one statement that we found. Notice that we'll point out later. Licensing data recovery environments, it's nothing but quotes out of the contract. So even though its content is indeed contractually binding, the document itself is not contractual. Technical support policy. We've already seen that it is directly integrated into the contract by reference, therefore it is contractual. The processor core factor table is contractual. It was advented around August of 2008, if we've noticed properly, and all templates since that time have integrated it directly into the contract. The Oracle partitioning policy document. Ladies and gentlemen, that document is not contractual. It is excluded from the contract because there is no reference, direct or indirect reference in the contract to it, and it meaning it's not in line, nor is it integrated into the contract by direct reference. It is excluded by the entire agreement clause. Oracle Cloud licensing policy. This was innovated 5 years ago or so, giving Oracle licensees in Amazon EC2/AWS environment certain privileges, and also Oracle on Microsoft Azure more recently has been integrated into this policy. It's not contractual, but the courts would grant or would recognize what the courts know as an implied license to this. You can certainly grant privileges through an implied license, but you cannot take away contractual privileges through extra contractual statements. The hosting policy also is not contractual. Now, all these non-contractual documents have this very clear footer that says, hey, you can't integrate this into a contract or agreement. That's interesting, but that's not what makes these documents non-contractual. These documents are non-contractual because they are excluded from the contract by the entire. On the left, we've got 2 physical vSphere hosts running Oracle workloads, vMotioning all over the place between them. Those Oracle workloads are cordoned off to where they can never move to host 3 or 4. And therefore, we license only where the programs are installed and or running. We don't license the entire cluster. Your contract is not cluster-based. It's not shared storage-based. It's certainly not enterprise-based. It's not even host-based. Now, there is one contractual exception here where the standard edition rack bundle, the contract specifies that that can run on a cluster that has a maximum capacity of 4 sockets. That's the only place for any edition of the Oracle database in any contract, new or old, that you will find a cluster level stipulation having to do with a database edition. All right, so open up your contract, scan it to text searchable if it's not already, and search for the word cluster. You'll find a reference to Microsoft SQL Server cluster. You'll find a restriction on the 10-day rule for any contract early 2008 and more recent that says that that free node for up to 10 days has to share a cluster with a protected node. You'll also find the rack standard edition bundle that I mentioned. Depending on your version, you may find a reference to WebLogic clustering, but you'll find nothing in here that talks about cluster-based licensing as Oracle represented for Oracle on VMware. While you're at it, search for the words virtual, VMware, shared storage, etc. You'll find nothing. So let's open up the software investment guide, which shows an example of exactly the best way to protect yourself against a full cluster licensing assertion. Here we have a cluster with 16 physical vSphere nodes. The 8 on the left we wish to run and or install WebLogic on. 6 out of 8 on the right we wish to install and or run Tuxedo on, and we're just mapping and or zoning our shared storage, mounting that shared storage that has those executables selectively on those nodes. Those nodes where it's not mounted, there's no licensing obligation. Notice up at the top of the screen there's a clause that said this is a non-virtualized environment. Nice try, but the software investment guide is excluded from the contract by the entire agreements clause. So Oracle on VMware licensees, since the contract is agnostic to VMware in every way, it is your privilege to ignore that non-virtualized environment statement. So back to the very well-written partitioning policy document that's existed in various names since 2002. It's unambiguous what it says. You may have been told that you can't soft partition your vSphere cluster. Well, by Oracle's own definition, the very first sentence, states that partitioning occurs when CPUs on a server are separated into individual sections for purposes of reducing licensing liability. It's a server-level concept. It's not a cluster-level concept. And the statement indicating that VMware is soft partitioning, and soft partitioning may not be permitted as a means to determine or limit the number of software licenses required for a given server. Beautiful statement, unambiguous. You don't have to worry about it because it is excluded from the contract by the entire agreement clause. Not all of our internal audit or audit defense customers have their legal teams check case law, but those that have, here's the sum total of relevant case law that has been found on this topic. I suspect that if Oracle knew it had contractual merit on any of these 6 assertions, that it would have filed a long time ago to protect its rights. So here are a couple of blog entries on the topic that you may be interested in. Oracle licensing, soft partitioning on VMware is indeed your contractual right, September 17, 2014, as well as managing Oracle licensing compliance in a shared storage environment, 3rd of October. Copious information on that. All right, Oracle support. You may have heard that Oracle's not supported or even not well supported on VMware. Nothing could be further from the truth. We've been doing this longer than anybody, and we've got customers all the way into the Fortune 10 space. No House of Brick customers ever needed to replatform to prove a bug in an Oracle environment, vSphere environment. That even includes when they come into bugs that aren't in Oracle's knowledge base. VMware Global Support Services does a wonderful job for those customers that are interested of taking full ownership of these tickets. And if you want more details on that, strong encouragement to take in what I think was best of show at VMworld 2014 US, Wednesday afternoon at 4 p.m. Find somebody in your organization that has a VMworld login and buy everybody lunch. Put this on the screen in the conference room and find out what's really going on with Oracle on VMware support tickets. All right, performance issues. Probably about 50% of our customers before they run into us get into some kind of trouble with Oracle on VMware performance. 100% of those issues have nothing to do with VMware. They're resolvable through configuration. In my own travels, and this is non-statistical, 70% of the problems come down to storage. Somebody is doing an apples to oranges thing that they would never dream of doing, a configuration in a production bare metal environment, but they're whether it is using a fraction of the number of disks or fanning in way too many workloads, consolidating too many workloads into a single LUN, saturating their SCSI queues, using better storage disk quality in a physical environment than a virtual environment. It all comes down, many times more cache in the physical environment than they have in the virtual environment. We hear a lot of people that say, well, we've tried our tier 1 workloads, whether it be SQL Server or Oracle or any other RDBMS brand for that matter on VMware, and the performance wasn't good, so we backed out. It's like, no, stop. There's always an apples to oranges issue having to do with what they're doing here. About 22% of the problems come down to memory. And I'll tell you the grand key secret here that drives nuts a lot of vSphere administrators that have been at this for a decade, and that is with tier 1 relational database environments, those database kernels don't know anything about physical disk. They read to and write from they write to and read from memory. They surround themselves with background processes or threads to do the I/O. So those databases, regardless of the brand, don't do very well when they go into swap in native hardware environments, and therefore we do not oversubscribe tier 1 workload database memory in a vSphere environment. CPU issues are very rare, and networks even more rare. But again, for all human detectable, end-user detectable perspectives, you're going to experience performance transparency, even with your most concurrent, execution-intensive, I/O-intensive workloads. And we could even show you a study. We didn't do it, but we could show you the full write-up on a study that even shows that with one certain type of NUMA workload will even outchase native hardware on VMware. All right. My favorite, I told you that I had a favorite and I was going to get back to it, DR. This for me would be justification alone to virtualize, even if I was throwing the VMware Virtual Shroud around a dedicated production workload. And that is, historically, with physical DR, we used to dual drill the IPs, the IP for the prod location, IP for standby, at every level of the stack. We'd use Oracle Data Guard in the case of an Oracle database, or the other database brands. We would use database layer transaction vector shipping or log shipping. But the problem is that didn't cover operating system patches or configuration changes, didn't cover any other utilities on that node that needed to be patched or reconfigured, certainly didn't cover patches or reconfiguration, major or minor, of the database software itself. People running around with clipboards between the production and DR site, marginal coverage, I discussed that already, and error when people typoed stuff or didn't get the change entered at all on the DR side or in time on the DR side. Full regression test was advisable, and low reliability. It rarely happens. Gartner published statistics quoted by EMC Corporation at Partner Exchange 4 years ago that stated that only 1% of production emergencies in the United States result in a DR failover production declaration. But in my non-statistical observation, it seems like as often as they happen, 20 to 30% of the time, people are still running around to try and figure out why the DR stack won't come up. And meanwhile, some of these shops have anywhere from $50,000 hard revenue loss per hour, forget the brand degradation, to it can mount to the millions while the systems are down. So then we throw the virtual shroud around the workload and use array or host level async replication to deal with the DR. If people still want to layer database level log shipping on top of that, that's fine. Still have to dual drill the IPs. You're approaching 100% reliability because now that virtual shroud is also capturing all operating system and application level configuration and patch changes. You can test on demand. That's a huge advantage compared to the difficulty, the expense, and the complexity of testing DR in a native hardware environment. Full regression test is still advisable because you're still dual drilling IPs and you could destabilize the stack in doing it. You may need to reconfigure the application to make this work. Then you get into what I call third generation DR, which we've seen for a couple of years now at GE Appliances and Lighting, part of the GE Fortune 8 family, fully referenceable customer. They're using technologies like Cisco OTV to provide layer 2 network simulcast 1,000 miles apart to between their production and what they call their alternate production facility. I love that name. And so they literally don't even have to do testing because they're not dual drilling IPs. The production IP is the same IP that's used at the DR site. They just have their business technical leads and the business units just check to see if the services are up. That really is the new state, the new gold standard for DR. Fewer layer 2 segments, wider segments, prioritizing the test just swing all the users every now and then and let them sit there for a week or two and then swing them back. And that's how they test. The business users are elated with this and they're queuing up. So let's talk about business continuity, especially having to do with SQL Server clustering or even Oracle RAC. I'm going to use an Oracle RAC example here, but 3 out of 4 of the criteria that we're going to talk about still apply directly to any cluster-enabled relational database. I've come up with, or House of Brick, we've come up with 4 criteria over the years that we challenge architecture teams to answer yes to at least one of these questions to justify further conversation or architectural brainstorm as to whether they want to introduce relational database clustering into a workload as opposed to using single instance of that database on VMware HA. do you truly have a formal service level agreement or even service level understanding with your business unit that they have to be up in an emergency in less than 4 minutes? Or do you have the need for rolling upgrades of the workload? I thought it was interesting that CETA, that was interviewed in the 2014 VMworld panel discussion, they did some study after the fact, and they discovered that despite what they had been told and thought, that 80% of the workloads that had been categorized as no, we've got to have rolling upgrade capability, after the fact they discovered that it could have been taken care of with an outage. Oracle has the Oracle Notification Service that will do publish, subscribe to any middle tier or coded workload to see whether the Oracle RAC components, hardware and software components, are up or down, or to see what their load balancing information is. And the software can actually take different logical branches depending on those notifications. It's extremely rare. I've only run into one company in all my travels, including my years of Oracle University RAC instruction, that was even considering using that. Never run into anybody that actually did it. Or, the truth be known, do you truly have a workload that needs more than 128 3 gigahertz CPUs, let alone hyperthreading? You know, that's 400 gigahertz of processing power. Do you really need that? If you can answer yes to at least one of those 4 questions, and we do indeed have customers with workloads that do, then you can still justify cluster-enabled workloads at the database layer. If yes to any of the above, a couple more questions for you. Are you able and willing to undertake rack design overhead at the schema level and coding level? It's much more involved to do rack literate design. And are you willing and able to undertake the stress testing to see if the rack interconnect between the multiple rack nodes is hostile, if the application is rack interconnect hostile and your performance begins to curve over, if not go negative? So if all criteria are no, consider single instance. You name your branded database on VMware HA. All right, so let's put them side by side here. Single instance on VMware HA, we've talked about the issues. One of the cons is if you lose that workload, you've lost 100% of it. Everybody has to reconnect. Rack can give me down to about 30 seconds of outage. If I try and go lower than that, I'll get false node evictions. So 30 seconds is about as far as you can go. It's complex, it's expense, there's a lot of development overhead, and there's higher threat that multiple instances might corrupt that shared clustered database. But now we've got SMP fault tolerance that fails over with not 1 second of outage, but just 1 second of performance dip. There's absolutely no client network disconnect at all, even though we've lost the entire hardware that that single instance was running on. The con is it's currently limited to, after hyperthreading, about 16 gigahertz of workload. There is some measurable latency with this. It's the first time we've ever seen that in a VMware product, but I'm not worried about that because the chips are advancing faster than the latency, and so we can overcome that through processor upgrades and refresh. If the horizontal scalability of 16 gigahertz isn't enough, great. Throw a rack on top of it, scale horizontally, and enable your customers with the world's best HA. Question?
Can I interrupt you real quick? So it sounds to me like what we're really saying with all of this is once we've made it through the contractual and licensing challenges, which are typically forefront on most Oracle and to a degree some of my SQL customers of mine, the next piece really goes, well, how complex does this need to be? And I know we've done a couple of engagements with our customers to where we've walked them through these HA options. And my favorite one, if I remember right, the numbers right, was it was 43 seconds to go through and shut a SQL server down and restart it and have it reserving transactions in 43 seconds, which was 15 seconds slower than a planned cluster failover in that world. So it really sounds to me like there's not really a lot of negatives to this as long as it's built correctly on top of your virtualization platform.
Right.
Am I hearing all of this correct so far?
You absolutely are. People have far more choices than they used to have. They used to only have poor man's HA, which is fail over to the DR node, which could be a 45-minute to an hour, after diagnostics and management approval and getting the word out. Or they'd have relational database level clustering with all of its complexities, with all of its, agnostic workloads running fine and scaling fine on a single taller SMP node, and now we try to cluster enable them at the database layer, and they go south. Not all of them do, but too many of them do.
And I also hear you not saying that. I'm sorry. I also hear you saying that we're not advocating that we need to throw out all of what's been done and is functional and working, but what we're looking to do really is challenge it to say, do we need to? Much like you did with your other customer, do we need to have this level? For the longest time, classic database HA came in, if you wanted it highly available, it was a cluster. Then it moved into, okay, well, we can do it at the application layer, not so much at the physical cluster. And most of my customers that struggle with databases in an HA fashion struggle with the clustering process, not the database. And I think that's a lot of what you've seen along the way too, right?
Exactly. And Bill, so 1/3 of House of Brick customers, and my non-statistical observation of 10 years ago, where relational database level clustering was the only way to get things done, only 1/3 of those we can still justify database level clustering for. But for that third, and I'll make a comment here based on your comment that I hadn't planned on making, database level clustering on VMware is a marriage made in heaven, because what it allows them to do is commit themselves with very little hardware expense and very little human install expense to full exercising of that code for database cluster compatibility. Most organizations that have that level of clustering only introduce the workload to the database level clustering in the last hop before production, because the hardware installs and everything are so expensive. Well, that's a little late in the game to discover that you've been doing all your dev that's functionally perfect but operationally hostile. And so with VMware, we could take these relational database clusters, and without hardware dependence, we can broadcast them back to the earliest desktop where this testing could and should take place. So if you need it, database clustering on VMware is a marriage made in heaven, especially Oracle RAC on VMware. All right, security. You heard me say that, well, I'll just say it this way. Security analysts, despite all scanning and everything else, agree that at the end of the day, the ultimate best way to reduce a security threat is to reduce the size of the attack surface. Compare a tightly controlled vSphere at 150 meg to multiple gigabytes of Linux or Windows attack space. There are many, many other reasons. I could go on for an hour on the security benefits of the virtual shroud compared to native hardware. Don't have time for that, but very enthusiastic for what I see happening in the market, both technically and in terms of adoption with VMware NSX. I have my eye on Starbucks that is taking a zero trust policy with their employees, and they're using microsegmentation, throwing it around every component of every workload. This works with ground-up networking with anybody's hardware, all the major vendors, or if you're trying to retrofit NSX into your legacy network configurations and security configurations, that works too. So that's my 2 cents. I could go on, but I don't want to consume all the available oxygen in the room, and just the overview of the various reasons that we believe that all the advantages that we've enjoyed over the years with Tier 2, Tier 3 workloads with virtualization, it's high time financially from a security perspective, DR, operational agility, lifecycle, you name it, HA, high time to introduce those benefits reliably with performance transparency into our most mission-critical workloads on top of our most mission-critical databases.
Thank you, Dave. So I'm gonna. We've got a few extra minutes here that honestly I wasn't planning for, so this is actually awesome. I like to kind of take it down the road of, okay, guys, we've talked with you about licensing. We've talked with you about benefits of virtualization. We've talked with you about operational readiness. There's been questions that have popped up along the way that have to do with, okay, I get it, but now how do I know that my workload, because my workload is a special workload, is going to fit in this world? And I will tell you that this is very much like the original virtualization process that you went through. This is a measurement process. We work with SQL tools, we work with Oracle tools, and we measure where you're at currently in this world so that we can take a look at and forecast and know how much you need to do. How much I/O do we need? How much memory do we actually need? What does a right-sized configuration look like in this world? And out of all of the ones that we have done, when our guidelines have been followed at the end of this process, from a platform build, virtualization, machine configuration tweaks that are not out of any normal parameters that can be done within the VMware footprint, we have had amazing success with this process. We have had SANs that have been in an all SSD format that we've taken a look at and said, you guys are wasting money on the SSD side. 50% of your data belongs in that SSD footprint. The other can be on slower spinning medium because of the way it's accessed. And so as we dive into these processes, we measure, we benchmark, we then look to pilot this process in a new configuration in that virtual environment and then begin that migration. So Dave, I mean, from a safety perspective, I can't think of anything that we could do differently or better in that world. I mean, did I miss anything from what we ended up doing
not at all, Bill.
most of the times?
Not at all. It's interesting. At the boot camps that I run, both public boot camps for 4-hour boot camps for Tier 1 virtualization on VMware, or when I do these internally at customer shops, we have no double standards. House of Brick's been a performance OLTP benchmarking team. We used to write our own injectors back in 1994, 1996. And we have no double standards for performance, throughput, latency, overhead on VMware compared to native hardware. As a database administrator, at the end of the day, our ultimate performance frontier is I/O. And go back to what now is a aged release, vSphere 5, pre-release 5, the MN release as it was known, the code name inside VMware. Back in 2010, then Chief Performance Officer for VMware, Richard McDougall, ran yet another I/O performance study and took that code and used the proprietary VMFS, VMDK storage presentation and crammed 1 million IOPS through it and scaled linearly from 1 to 1 million IOPS in a single vSphere server with a whopping 100 microsecond I/O virtualization latency wedge per IOP. Absolutely undetectable from a human perspective. And I even had a chat one evening with Stephen Herod, the former CTO of VMware, and I said, you guys need to stop doing these presentations, your keynotes, Stephen. Wednesday, you got up there and you said, slide for the world to see, that the ceiling, the I/O ceiling for vSphere 5 was 1 million IOPS. It's like, Stephen, you guys ran out of hardware. You have no idea where the ceiling is. You scale linearly to it, so stop, stop saying those things.
Yeah, it's funny, Dave, because the client that we're currently working on together, we managed to find that we weren't able to bottleneck the storage. And for the first time in my career, we were able to bottleneck 8 gig fiber channel with real, actual database workload. So, I mean, it's not vSphere that is in the way of this process. With the release of vSphere 6, with the ability to scale to 63 terabyte LUNs, with the ability to scale to the processors and memory footprint that we're at, honestly, now the limitation from my perspective becomes architectural imagination of how far can we push it, what can we really lump in these machines to get this workload out of it. I'm not going to look at you and say that that all databases are virtualizable, but I would challenge. And that's the only place you and I are going to differ today at this webinar.
That's my next comment. No, my next comment, and that is, people say, well, I've got a 38 terabyte database. I can't virtualize that. Of course you can. The ability for a database to be virtualized has absolutely nothing whatsoever to do with the byte footprint of that database. Other than when you're coming from RISC Unix to x86 and you may want to use asynchronous tools over a period of a week or so to do the move with a just very brief outage of a couple of minutes to cut over. But you can virtualize a 20 petabyte database as easily as a 20 gigabyte database. The things that matter with virtualization are concurrency, which is an issue of CPU. Okay, and I've got 400 gigahertz of CPU processing power, so okay, we'll have a conversation about that. Memory, all right, or up to some ridiculous limit that I can't even remember of terabyte or 2 terabytes of RAM per VM. So you want to virtualize SAP HANA? Great, let's do it. No problem. It's not rocket science.
Dave, and I love that about you, and I love your aggressiveness on that side. So, guys, I have not seen questions pop up. So, Kyle, if you've seen questions pop up in the webinar, and we want to ask a few questions before we look to close things down and out, I'll give it a few minutes here. So, if anybody's got any questions,
hey, I've got
type
ideas
them on
with what we can do with the time here. Let me just go ahead then and verbally describe where people get in trouble with storage. There are 5 layers where they get in trouble with storage. Number 1, in a Tier 1 production environment, they may only have 1 or 2 workloads on a physical server, Oracle or SQL Server workloads, but yet in a vSphere environment, they may have 15 or 20 VMs, including a prototype benchmarking VM, and, well, gee, you might be overrunning the box with a benchmark on top of all those the other riffraff. And then they may have concurrent multipath I/O from down to the storage and prod, native hardware, but in the virtual environment, they've got single path. In prod, they may have 196 gig of SAN cache, and in test, VMware test, they may only have a couple gig. They may, in prod, have a grundle of spindles, and they're high-quality fiber channel spindles, for example. And in VMware test, they've got maybe 5 spindles that are SATA. Prod's configured RAID 1 plus 0, SATA's configured RAID 5, and they try their Tier 1 database workloads on VMware, but the performance isn't good, so they back out, and it's like, okay, so what about this picture, this apples to oranges picture, don't we understand? If we provide the same kind of rich storage configs, and that's not to say we need to stay with them, you can take your baselines and see how far you can push it, and then you can begin to intentionally dumb down the test environment to figure out where your performance curves scale over, But that's the biggest right there. If people avoid those 5 sins, the apples to oranges sins of storage config, they'll avoid 80% of the storage troubleshooting that we do and remediate in our professional services that have nothing whatsoever to do with VMware. I've already
Dave,
talked
thank you
about
very much for
memory.
that. Yep.
Yeah.
So, guys, I just want to say thank you all very much for attending. It's always impressive when we have so few people actually drop in a webinar. Thank you guys so much for spending the time. You see Dave's contact information up on the screen. Please don't hesitate to reach out. Reach out to your sales team. We can get you guys involved with House of Brick, because I'll be honest, what we do on the virtualization and hardware footprint is only complemented by what House of Brick brings to bear from a data and database virtualization. This becomes a complex process and problem, and we need to make sure that we're looking at all avenues and aspects. And honestly, that's why I love working with these guys, because they are experts in their area and they know their piece incredibly well, and then they rely on others, customer environment people, and people like us to really help make this a complete winning package. So, Dave, thank you so much for taking the time today.
Hey, Bill, this is Kyle. We did have a couple questions come through. I guess one they wanted to see if you could explain the Oracle ASM on the VM.
Oh, sure. Be happy to. ASM, we strongly recommend Oracle Automatic Storage Management, whether it's native hardware, single instance, or rack-enabled workloads, or whether it's VMware single instance or rack. ASM is a raw device mapper. It's not going to do anything to induce performance latency. The only time that you would not use ASM would be if you're using direct-mounted NFS, either on native hardware or in VMware. Now, we do actually have a customer that demands, because it's not a block level presentation, right? And ASM maps a block level storage. But we do actually have a customer that insists on using ASM for everything. So they actually go in with DD commands and they take the NSF filer and they chop it up into what look like block level devices. We don't recommend that, but they're doing it. So yeah, ASM everywhere, native hardware or virtual, with the exception of direct mounted NFS.
Perfect. Dave, one question that also came up apparently is you had showed the diagram earlier on in the slide deck where we had things broken up into separate clusters. Do you generally, or does House of Brick from a best practice perspective generally recommend breaking things up into dedicated clusters or Oracle clusters specifically? What would be kind of a reason and justification for not putting that in your general hardware or general virtualization footprint?
Sure. I'm not at all interested in avoiding an argument with Oracle over that, because when you push all the way through on Oracle's arguments that have no contractual merit, including this full vSphere cluster licensing argument, you win. Oracle understands it has no contractual merit on that, and you win. It may be that if you're concerned, now if you're a scaled organization, you're probably got enough workloads that you can go ahead and dedicate a physical cluster through your own crass selfish viewpoint, not because of pressure from Oracle on licensing. But let's say that you're not an extremely scaled organization, and maybe you've got a grundle of vSphere nodes in a cluster, and it's convenient for you operationally to have them all in the same cluster. Maybe you want your non-Oracle workloads to have deprioritized one-way inbound privilege on the Oracle subcluster when not a lot's going on over there. The big issue that you just have to worry about is that when you set up, and the Oracle contract, of course, is silent on what tooling you use to establish your subclusters. But let's say we use DRS host affinity rules. That happens to be the best, greatest, easiest way to do this. You just have to make sure that your vSphere administrators, including as the years roll on and new people come in, that they understand that that's not something that they mess with, because if they open that up and allow those Oracle-laden virtual machines to float across the entire cluster, they could be inducing a licensing liability if procurement and DBA management indeed did not have a license shelf entitlement to cover the entire cluster.
So to summarize it, if I had I know a lot of times, let me go this way. I know a lot of times when we've worked together for our customer and customer subset, a lot of times we've even gone so far as to build specific hardware, specific memory footprint, maybe even add in caching type devices that allow us to get more out of it. So that separation becomes easy. But if I can put that in a general, let's go 8-node cluster, and I only really need to run Oracle on 4 of them, I can use my affinity rules for a DRS affinity rules perspective, tie those to that, and then that's going to satiate Oracle's licensing needs. So it's not full cluster, it's where they're running, like you had stated earlier.
And here's the other way that you further avoid some new employee or somebody forgetting that they can't open that up and allow those Oracle-laden VMs to float. Go right back to that slide in the software investment guide that talks about selectively mapping or presenting software-laden LUNs or storage selectively into your various nodes. Because, if you've done that, then it becomes pretty dang impossible for a workload that can't execute. If the Oracle executables are installed on shared storage and the storage is not physically presented to where it doesn't
other
belong.
nodes in the cluster, it really kind of prevents that from happening natively.
Exactly. It's
so
not
we can tag team that process. I like it.
Right. It's not necessary for you to do that type of selective, referring to fiber channel as the example, LUN masking or zoning. It's not necessary for you to do that to be contractually compliant, but it's like the ultimate insurance policy to make sure that you don't have an operational slip-up that induces a licensing liability.
I like it. So Dave, and then we're going to close with this last question. There was a question in regards to number of CPUs. So let me kind of give a little background to this one. I know that as we have been working together and watching things, and watching VMware and VMware's evolution, we've always looked up and said, right size your CPU. What you had alluded to earlier, when you're coming from hardware with multiple cores and extra capacity because you're managing to that bursted workload, a lot of times people look at that and go, well, I've got 32 cores over there. I'm going to create a virtual machine with 32 cores in this world because it has to be a one-to-one configuration. From an experience perspective, I know that for us, a lot of times more CPUs doesn't equal more performance. It typically will hurt my performance in an SMP environment like this, where I've got CPU sharing, resource sharing, things going on at the virtualization layer. So how do you, what's the maximum vCPU you would generically see prescribed across a typical Oracle or SQL workload? Maybe that's the best way to ask that question.
2. People cringe when they, no, I'm serious. People cringe. But, you know, go out, and it's exactly what you said earlier. I'll use my words. Baseline, even with all your SQL access path SINs, everybody has them. They come in from vendors, or we create them on our own in the development teams. Go out and baseline your bare metal production environments, average and high watermark CPU. And then take that bare metal server model through the publicly available spec organization, the Spec Int Rate 2006 tables, and compare it to your refreshed hardware and your vSphere environment. And oftentimes the CPU lift is phenomenal. I did one not long ago where the customer was on fairly aged Sun hardware, and we had a CPU consolidation of 8-to-1, and they were still swimming in capacity. The whole environment would be, we could disable one socket on a 2-socket vSphere blade and run the entire environment with wonderful noisy neighbor isolation with CPU to spare. All right, and so people assume that they need all the CPU. No, do the math. It's a spreadsheet exercise. Actually, take your actual prod numbers, and if you don't like your average, take the high watermark. Err on the side of being conservative, and run it through the tables, and then, you know, go ahead and put some slack in there. If you want to put 25 or 50 or even 100% slack for CPU in there, go ahead. But that's not going to have you provisioning 8 and 16 and 32 vCPU VMs. It just won't. 2 cores is standard. 4 core is exceptional, but to go beyond that, there just aren't that many workloads that need more than that.
And so that takes us right back to where you stated earlier, right? Number 1 problem you guys troubleshoot is I/O. Number 2 is memory. 6% of your problems on average are CPU and CPU specific, and that resource is probably the easiest one to fix in a virtualization environment. So before we get too much further, guys, we're officially out of time at this point, at the top of the hour. Again, thank you all so much for attending. Dave, once again, bravo for your work with Oracle. More contractually than the database side. It sounds like the database side is relatively straightforward if you can make it past the licensing pieces. And amazingly enough, you have a complete practice built around helping people correctly right-size their licenses. So guys, there's many options to talk about here. Please get a hold of us. Again, thank you a ton for being here.
Bill, it's always a pleasure.
Have a great day, everyone.